Okay, so we are live. Let me share the screen. Okay, so our today's GFG's POTD is rightmost different bits. So here we have been given two numbers m and n, and first of all we need to convert them to the binary numbers and find the rightmost basic that is not same in both of them. So let me explain it to you. For example, we have two numbers m is equal to 11 and 9 is and n is equal to 9, and their binary representations are 1011 and 1001, and as we can see that their first bit is 1, which is same, but the second most bit is 1 and 0, which are different. So we need to return that the second rate most bit is different. Okay, so how we can approach the problem is, first of all we can just initialize the counter variable into 1 and just simply traverse the digits of its binary representation. If they both are different, then we can simply return C. Let's see, we can increment C and just we can divide number by 2 to get its next digit, and that will just simply return S1. Okay, so let's try running it. Okay, so yeah, it's MNN. Okay, let's try submitting it. So as you can see, it got submitted. This was all for our GFG's POTD. So now over to you, Sangam.
Yep. So, guys, the question that we have been asked today in today's Leetcode PODT is that there is an array that is given to us, and the array it is in the form of a 2D array. Now, what do I have to do is we have to find the image smoother of this array. Now what does this mean? Because here they are trying to elaborate us, or they are trying to explain us that what is it, but they just make it much more complex to explain the thing. So now let's just understand it in a simplification manner by the help of this array. This is our given array. Okay. Now the thing to understand here is what does the image smoother means. Now if you see the function that they have provided us in this case is that they are asking us to return a vector vector. That is literally the thing is they're asking us to return an 2D vector which will be of similar the size of the input vector. Okay, so as this given vector is in the form of 3 cross 3, so our answer vector will also be in the form of 3 cross 3. Now the thing is that what we have to do is we have to put some values in these boxes. Yeah, and that is what we are going to return. Now the condition arises that how we can actually put values in these boxes. So what we have to do is, let's say this is a box that I had. Okay, I just have to find all the elements that are surrounded by these box. So let's say if it is in the middle of the subarray, then it would look something like this. Yeah, the subarray or the vector would look something like this. Now, so the array element that is present in this box, 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 and in this box. They will be added, they all will be added along with the element that is present in this box, which we want to do. So it will be added with this one, and we are simply going to divide it with the number of boxes that we are considering in this case. So in this case, as you can see, we are considering total of 9 boxes, and whatever the value that I'm going to get in this case, I just have to do the floor of this value. Okay, floor, what does floor means? So let's say if the answer that is coming out to me is 3 and boxes that I have is 4. So when I divide 4 or 3 by 4, the answer that I'm going to get is 0.75 something. So floor value means I'm not going to consider this point value, I'm just going to consider this 0 value. So that is what we have to return in this case. Now, as I already explained to you, that this is what we are going for. We are going for the sum of the array elements that are present at the neighbor side in the eight directional ways to the given element, and also considering the sum of that element. Now if you see in this subarray, let's say we are assuming this block. Now for this block only, if you consider carefully, we have only 3 blocks which we can consider to be its neighbor, because other than that, this one or either this one or either this one, these are all actually out of bound zone. We can't find something out of it, so this one is out of bind zone. Now the thing that we have to consider is the array elements that are present here. Do the sum of them and do the sum of this. Okay, so the overall thing is that we are considering in this case this whole block to find the value of this element. Okay, so if you see, the total blocks are what, 4, because that is what the count of 1 2 and 3 and 4. And if we do the sum of the array elements that are present here, 1 1 1 1, which is also 4, so the thing that we are going to get is 1, and that is what we have to fill here in this case. Now considering the box here, now let's just consider this one. Okay, so as you can see, for its neighbor can be either this one, it can be either this one, or it can be either, yeah, so it can be either this one, this one, this one, this one, this one. This will be out of bound, this will be out of bound, and as well as this will be out of bound. So if we consider it carefully, we are total of considering 6 blocks in this case. Okay, so the count will become 6, and what is the sum of these elements? 1 1 1 1 1 1, it is actually 6. So as a result, here we are getting 1 as our answer. The same thing will be applied for all the boxes that are present in this case, and that is what we have to return. Ultimately the solution would be. So as I hope that I be able to make you understand, guys, what is the problem is. The problem is simple. If this is the sub array, or if this is the 2D array that is given to me, and I have to find the value of a particular index that I can put in my new sub array, the thing that I have to do is I just have to consider the 8 neighbors of this array. Okay, I just have to consider their value, do the sum of these value, do the sum of to the value that is present in between, and then divide it by the number of these are elements I am considering. So as you can see, in this case I am considering 1 2 3 4 5 6 7 8, and then this one, which is 9. So the array or the count of array elements that I'm considering in this case is 9, and sum can be anything. Let's say it is 27. Yeah, so when I divide 9 by 27, the thing that I'm going to get is what, 3. So in my new subarray, if this is the block we were considering about, here the value we are going to put is 3. Okay, and that is the principle we are applying in this question. They have, like, the way they express this code, or the way they have expressed this problem, it just kind of a confusing one, like image decider 3 cross 3 this and that. but when you observe it carefully, this is what this problem is all about. So now let's just move on to the solution code, like how we are actually going to solve this problem. So first of all, what we have done in this case is, as you can see, we have taken an array, and this is the image array that is given to us, and we have taken the size of it, which is nnm. Then we have declared a vector which is res, and it is of the same size as that of the image array. Okay, then simply we are just traversing through each element, each element, that is via our nested loop, that is these two loops. We are just traversing through each element. First of all, we are going to remove this, then this, then this, then we'll come to this, then this and this, and so on and so forth. That is what we are doing via these loops. The next thing is we are here calling the smoothen function. Now here the trick that we have to consider while solving this problem. This is the key part. Okay, so now see, here I have again taken the two sizes, that what will be the respective size of the image array. Then I have taken two variable. First one is sum and the other one is count. Then what I'm doing in this case is I am traversing via these two loops. The only thing that I'm doing in this case is I'm just traversing. I'm just finding the elements that are present in the eighth direction. So if this is the value or this is the array element, then I'm just finding the eighth directional value. What would be the value at here, 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 what would be the value at here. That is what I'm doing in this case. I have started from -1 and I'm going till it become 1. Then again I started from -1 going till again 1, and then these will be the new row. So how this thing is going to work, let's say in terms of array index it will be 0 0 0 1, then it will be 1 0 and 1 1. Now if you consider carefully for this block, okay, row element is what, 0, column element is what, 0. Now if I look at up above, or if I want to go above, you can see that in the row wise I just have to decrement the row. So row will become here what, -1, and the column, you can see column will remain the same. There is no change that I have to do with respect to that. So the place that I'm going to reach is what, -1 and 0. And as you can see in this subarray there is no place like -1 and 0. So as a result we are simply going to discard this value. The same thing we are going to do for this case. So when I want to reach here, what I'm doing is I am going up above the row side, and also I am going negative to the column side. So here in this case row will become -1, column will become -1. And as you can see, -1 and -1 is not present in the subarray, so we are simply not going to consider it. The same principle is what we are going to apply for these value, this value, this value. Yeah, and that is what we are doing here. We are just finding out the new row and new column, and then we are applying the condition that if the given row that we have found now is within the image matrix, and the given column is also within the image matrix. If it is, simply add it to the sum and increment the count. Now after I do this math, let's say for 0 0 the array element total will be what, 1 2 3 and 4. So here sum will become whatever it is, and I am also incrementing the value of the count, so it will become 1 2 3 4. So it will become 4, and then at a final point what I'm doing is I am just returning the sum divided by count in my I and j value. So for this value I am simply returning the value of sum divided by count, whatever it can be. And by performing this function I am simply then returning the code. So as you can see, it is working perfectly fine. The trick is quite simple. Just consider the array, consider the array element, and find the all neighbors of this array element. Then check if they are valid. Check if they are valid. If they are, add it to the sum, and increment count, and then at the final value just return sum divided by count to our new array. That is what this problem was all about. So guys, with that, today we have solved both GFG and Leetcode POTD. We hope that you guys be able to understand it. With that, over to you, Shivam.
So yeah guys, thanks for joining us. We will catch you up tomorrow.
Yeah,
Thank you
guys.
guys.